Hi everyone, so this is another data analysis video. Following on from the previous video, in this video I'm going to talk about standardization of data. So in the last video I talked about normalizing data, which normalization and standardization are both methods of scaling variables or features. Normalization puts scores on a similar scale so they can be compared. Often that's going to be on a scale between 0 and 1. What I'm going to demonstrate in this video is standardization, and that is usually conducted to transform the data so that the variable has a mean of 0 and a standard deviation of 1. So this turns it into a z-score, and it has the properties of the standard normal distribution when we perform this type of standardization. So we're giving it parameters that match the standard normal distribution. Given that, standardization is kind of most useful when the data you have follows a Gaussian distribution. Okay. And it's also useful when you have a lot of outliers in the data. Okay, so when we standardize, when we normalized in the previous video, we put everything on a scale from 0 to 1, so there were upper and lower bounds to the scale. But when we standardize in the way I'm going to do here, it will create a mean of 0 for the data distribution of data, a standard deviation of 1, but it can have any upper and lower values. Obviously, the further they are away from the mean, the lower the probability of seeing values of that side. So I'm going to basically in this video I'm going to start with I'm going to show the z-score method of standardization. I'll do that manually, and then I'll kind of demonstrate how to do a similar sort of thing using a machine learning software library, Scikit-learn, which is really useful, has a lot of functionality. Okay, so the formula for the z-score, if you've done statistics previously, you're probably familiar with this, is to get your kind of z-score, your scaled z value, you basically take that value, you subtract it from the mean of the variable, and then you divide by the standard deviation for that particular variable or feature. What I will do here, first of all, is import some software libraries that we will be using that might be useful here. So I'm going to import pandas as PD, numpy as np, matplotlib.pyplot as plt, scipy.stats as stats. Scipy is also quite a useful one to have when you're running statistics. I'm going to import seaborn as well as SNS, because I'm going to use seaborn, which is kind of built on a base of matplotlib. I'm going to use seaborn to create some distribution plots so we can see how the scale of the variable changes once we use this z-score standardization. Okay, so I'm going to import some data. I'm just going to save it as a data frame object called df. I'm going to use the pandas pd.read_csv method, and I'm going to use the whitewine.csv data that I used in the previous example when we were talking about data normalization. So there's the header of that data, a number of different variables. The ones I'm going to focus on in this particular video are fixed acidity, which you can see there, various scores, and the pH value here, which has various scores. Okay, so if I use seaborn to kind of generate distribution plots of each of these variables. So the first one is fixed acidity. You can see that the mean of this distribution is kind of roughly it looks like it's between 6 and 7. Okay, and that on the existing scale. So it looks like on this scale, the scores run from kind of maybe 3 up to about 14, with fewer scores at the top. And if we do a similar sort of thing for the pH variable, so if I run that, what we'll see here is on the existing scale for pH, so the pH quality of the white wine we're looking at, the mean looks like it is around maybe just above 3.1 on the existing scale. So maybe about there, it's probably between 3.1 and 3.2, something like that. Okay, so what we're going to do is Z transform these, so the mean is 0 and the standard deviation in the data is 1. So before I do that, I'm going to make a copy of the data, so because I'm going to demonstrate similar sort of thing with Scikit-learn. So I'm going to create a new data object called scale data. I'm just going to make a copy of our data frame object using df.copy. And then I'm going to apply the z-score formula. And what I want to scale these two variables. I'm going to do both of them at once. I'm going to scale fixed acidity and pH at once. I could do them separately, but I thought it's an opportunity to demonstrate some slightly different coding in Python. So I'm going to use a for loop, and what I'm saying is for col, for the sound of column, in, and then I'm passing it a list of the column names that I'm interested in, which are fixed acidity and pH. So for each column in that has in this list of 2 items, so there's two columns essentially, and then what I'm doing is I'm saying take scale data, which is our data frame object, and col, the column, and then the bit after the equals sign, which is you can see it's a division. It says in parentheses scaled underscore data, which is our data frame object, column minus scale data column dot mean, divided by scale data column dot standard deviation. So hopefully that you should straight away be able to tell that is exactly the same. It's just a coded way to write that z-score formula there. So it's going to iterate through the values in each of those variables, and it's going to use this. It's going to take each value, subtract from it the mean, and then divide by the standard deviation to give us a z-score. Okay, and hopefully you can see that's what it's doing. It's saying take each of these columns in turn, subtract the mean from each of the values in the column, divide by the standard deviation of the data in that column. Okay, so let me run that. And what I'll do is I will plot those two variables again. So remember the first one, which is acidity, has a mean of about 7, and pH had a mean of maybe about 3.1, between 3.1 and 3.2. If I run that again using the displot, you can now see that the mean is 0 and the standard deviation is changed. So the scale has changed. So it's now got a standard deviation of 1 and a mean of 0. So we've manually, let me do the other one as well. You'll be able to see that has changed. So pH has changed as well. It's now got a mean of 0, standard deviation of 1. Okay, so we've standardized the scale on which these two variables are measured. Okay, so then they now have the parameters of standard normal distribution. As I said before, when you're doing this, you really need your data to approximate or closely match a Gaussian normal distribution. So that's how to do that manually. But we can also use the standard scalar method to do exactly the same thing, really, from Scikit-learn. So Scikit-learn is a machine learning library available in Python, and it allows you to do an awful lot of different things. Right, so what I'm going to do here is I'm going to import something called standard scalar, which is a Scikit-learn method function that is going to do this for us. And I'm going to set it to an object called SC, essentially. So 4 steps when you use Scikit-learn are you kind of import whatever the method or function is you want to use, you instantiate it in some way, so if it's an object, you then fit, and then you use it to predict from your data routinely. So what I'm doing here is I'm using from sklearn scikit-learn.preprocessing, so it's got a number of methods for preprocessing. Standard scalar is one. I'm telling it to just import standard scalar, and then I'm saving standard scalar as an object called SC. Okay, so let me run this, and then after importing and instantiating as an object, I'm going to fit the pH data. So we'll just focus on the pH the pH variable from the original. Note here I'm using the original data frame, so the one that is this variable has been unchanged by the manual processing we did, because remember we saved that as a separate, we made a copy of that and saved it as a separate data frame object. What I'm doing is I'm using sc.fit, so standard scalar.fit, and I'm then just passing which variable from our data frame we want to use. If I run that, we got this pop-up here. Usually this would just be some text like a string, but I've trusted the notebook here, so it appears as in kind of like this nice HTML image for some reason. So next, I'm going to create a new scaled data object that it's basically a column vector for this variable, as we didn't save it to the data frame as a new variable. So I kind of changed the existing variable in place, so to speak. But if I save it, give it its own object name, what I'm going to do is then use standard scalar.transform and then pass the variable from our original data frame. If I do that, so that has now we use the fit method to start using standard scalar, and now we've transformed it using standard scalar. Okay, and we can then reshape this column vector into like a one-dimensional array. So what I'm doing something else here. Don't worry about the details too much. These are kind of steps that you learn when you kind of use Scikit-learn a little bit. So I'm taking our data frame object and I'm doing reshape with it. So I'm turning it into like a one-dimensional array. And if we now, which is essentially a list of numbers. And if we now plot, use this plot to plot this object that we've transformed, what we should see is standard scalar has, using Scikit-learn, we've done the same Z transformation. It now has a mean of 0 and a standard deviation of 1. Okay, so that was the pH variable, which originally had like a mean of 3.1. So that's two ways to do the same thing. So we've standardized data using the Z-score formula by coding it manually. And then we've done exactly the same thing using a few steps by getting Scikit-learn to do it for us, using standard scalar pre-processing steps, fitting it and transforming it, and that returns this essentially. So we now have this object that it represents that data variable. So if we wanted to go in reverse and change this variable back to the original values, we basically just need to perform some algebraic manipulations, and we can and use this formula essentially. And if you kind of look at the original formula, if you did a bit of algebra on this to get back to this array, so to get back to this original value, you can multiply through by the standard deviation and then add the mean, so to speak, and that will give you this. So original value is the scale value times the standard deviation plus the mean. So we could, if we really needed to convert it back to the original, we could do that. As I said before, I often kind of save. If I change a variable, I often kind of append it so the original variable is still intact. It's just kind of something I prefer to do. All right, so that is standardization. So when would you perform this type of standardization? So in the previous video, we looked at normalization, which was putting things on a scale from 0 to 1. You do this type of scaling. It's usually required when we use some sort of machine learning algorithm that requires the calculation of gradients. So something like linear regression, logistic regression, or if you're using neural networks where and you're doing things that involve a lot of data to be processed, to be analysed. So there's no sort of right or wrong answer as to when to use standardization or when to use normalization. So in this case, we're demonstrating standardization. If you are using something like a neural network, or yeah, then normalization is probably preferred, because we we're not often, when you have data obtained from a neural network, you can't make any assumptions about the data distribution. And as I said before, standardization is often preferred when you have data that follows a Gaussian or normal distribution. It's probably not very useful if your data doesn't follow that type of distribution. Standardization is also probably the thing to do when your data is fairly normal, but you have outliers, so you have quite a number of outliers, because it doesn't it puts it on a scale with no upper and lower values, so to speak. Okay, so that's standardization. I'm going to do another video kind of demonstrating how to do standardization and normalization in Scikit-learn, just some more examples of that. But hopefully this was useful.